happens if we're given the graph, an absolute value function, and we would need to write the function that goes with the graph? So we've talked earlier about the idea that A is going to give you the compression or the stretching, and also if it's negative, the reflection. C is going to give you your left or right transformations or horizontal, and D is your vertical translations. So let's look at what this graph does and then figure out what's going to happen to the equation. So the first thing I like to do is say, does the starting point shift? So originally it would always be at 0, 0. Does it shift to get to the new vertex? And if we look at this, we can see that it shifts left 4 units and down 2 units. Then I like to look and see, is the slope or the steepness changed at all? So if I look, this is going up 1 over 1. So in other words, A would be equal to 1. So now I can write my function by filling in y equals, A is 1, then we have the absolute value, because this is an absolute value graph, x, if it's going left 4, then we're minusing a negative 4, and then down 2 is minus 2. And to simplify that, we don't need to write the 1, so we can just write absolute value of x minus a negative is plus 4, and then minus 2. And then we get our equation that if we were graph would give us this graph. So let's look at a second example. So let's look at all our parts. First, A is going down 2 and over 1. So first of all, we should see it's reflected. So A is going to be negative. And then if we look at the slope, it's 2. It's stretched by a factor of 2. Then we look at our transformations from 0. It is going right 3 units. And it does not move up or down at all. So again, y equals the negative 2 absolute value. X minus right is positive, so x minus 3, and then there's no d. And then we have our graph of our equation that matches the graph.